All right, you guys, so today our essential question is, why do we find like terms? So what are we going to do with it? So just as a reminder, like terms from yesterday and the day before are terms that have the same variable component. Okay, for example, like 5x and negative 7x are like terms. And then on the other side, like 9 and 0 and 15 are all like terms, okay? Or, we could have negative 1 also in there. So like terms are things with the same variable component. These ones on the left, the red ones, have x's. The blue ones have no variable, okay? So we find like terms because when we have really big and complicated expressions, we want to simplify expressions. So let's talk about what it means to simplify. To simplify means to write an expression in simplest terms. So basically, simplifying an expression is like you have a really big expression and you want it to be 1 or 2 characters long instead. So it's like a nickname for an expression. So instead of saying 18x plus 2x minus 17x plus 33x, you write just one term because you've simplified it into the simplest terms. So let's do an example. We're going to start out a little bit easy. So we've got 4y plus 7y. So normally we'd write down the terms and then the like terms, but this time I just want us to look at the like terms. Okay. So when I think about like terms, I'm thinking about terms that have the same variable. And I notice that the 4 has a y and the 7 has a y. So these two are like terms. I'm going to put a box around them. They're like terms. So 4y and 7y. They're both positive because we don't have a negative sign in there or a subtraction sign. So since they're like terms, I can combine them together. So this is like I have 4 yaks and my brother has 7 yaks. How many yaks altogether are we going to have? So I can combine them. And I combine them with addition because that's a sign in the middle. 4 yaks plus 7 yaks is 11 yaks. So this becomes 11y. This is the simplified expression. Simplified. Okay, and I can tell it's simplified because it's smaller or shorter than the previous one. So the previous one had 2 terms. This one has 1 term. But they're equivalent because they equal each other. Because I didn't get rid of any yaks. I didn't change any yaks. I just combined the yaks that I already had. Okay, so let's try another one. Okay, this one's a little bit more tricky because I've got 3 terms and there are some things that are hidden here. So the first thing I'm going to do, just like last time, is I'm going to write down my like terms. Like terms. Okay, for this one, I noticed the 12 has an x, the 3 has an x, and the negative 1 has an x. Now, you'll notice that I said negative 1, and that's because, if we recall from before, if there's no coefficient or no number with the variable, then there's an invisible 1. Okay, so this negative x is actually negative 1x. Okay, so my like terms are 12x, 3x, and then the last thing that's tricky here that we don't quite see is that this is negative 1x. So I've got to keep that negative 1 in there. Okay, those are my like terms. Okay, and now I'm going to simplify them. Since they're all like terms, they're all like each other, I can just add them or subtract them across the board. So I have 12 xylophones. Alex has 3 xylophones. And Ciara needs to borrow 1 xylophone. So I start by adding mine and Alex's together. 12 plus 3 is 15 x's. And then I still have that minus 1 xylophone, okay? And then 15 xylophones minus 1 xylophone, that's 14 xylophones. Okay, so this again is my simplified expression because I combined the like terms and I made it smaller. So originally I had 3 terms and now I just have 1 term. Okay, in the next video we're going to do a few more examples.